This little video is going to be about calculating concentration, and we're going to use the term molality. Molality is often used instead of molarity because in molality the units are expressed in terms of moles of solute over kilograms of solvent. And so since we're not talking about the volume of the solvent, the temperature effects that can affect volume are not seen. So scientists often use molality to negate or to avoid the effects of temperature on their calculation. All right, we're going to do number one on that same worksheet that you have at your table under the category of molality, so the bottom of the page. So this is number one. So in number one it says, what is the molality of a solution that is prepared by mixing 25.6 grams of sodium chloride with 478 grams of water? The formula for molality is lowercase m, and it is going to be equal to the moles of solute divided by the kilograms of solvent. So this is a little different than the molarity formula. All right, so let's look at the problem. What do you know? We don't have any moles and we don't have any kilograms. But that's okay because you can use your dimensional analysis skills and you can change your grams to moles and then go ahead and change the grams of water to kilograms. Not a problem. All right, so let's see what that looks like. So first, let's tackle the moles part. So we'll start with 25.6 grams of NaCl. Okay, that's grams. And we're going to convert that to moles of NaCl. All right, so we divide by the molar mass of NaCl, and that is 58.44 grams, and that's how much is in 1 mole of NaCl. So 25.6 divided by 58.44 is 0.44. So 0.44 will go at the top. 44 goes at the top. And that's moles. Now we need kilograms of solvent, but I see I have 478 grams, so I need to change that to kilograms. So I can do that in my head by moving the decimal 3 places to the left, and I get 0.478 kilograms. So now I have the correct units, moles over kilograms. And so when I divide that 0.44 divided by 0.478, I'm going to get 0.92 as my answer. And you could write moles per kilogram if you want, or you can just substitute in a lowercase m. Either one is fine. All right, so let's go over what we just did. We're calculating molality, and molality is a lowercase m, and it is moles of solute divided by kilograms of solvent. We have to be careful in this problem because both of them are given in grams, and so I have to know what's the solute and what the solvent is. So remember, solute is that which is being dissolved, the stuff being dissolved, and the solvent is that which does the dissolving. So once you're clear on that, it's a matter of just converting numbers. So we took the 25.6 grams of sodium chloride and we converted it to 0.44 moles, and then we took the 478 grams of water and we converted it to kilograms. We went ahead and divided those and we got the molality to be 0.92. Let's look at what way they could trick you on this one. Pretty much the problem we just did contained all the tricks. So molality, lowercase m, is moles of solute over kilograms of solvent. All right, so obviously instead of moles, they probably will give you grams, and that's no problem. Just go grams to moles. Use your stoichiometry, dimensional analysis. And then you have kilograms down here. Most likely they'll give you some other unit. Most of the time it's grams, and you're going to have to change that to kilograms. So that's the major tricks that you'll see in these types of problems. All right, go ahead and finish that worksheet. Again, the answers are found online on our website, Edmodo, and the last thing I will also put them on the front board for you to see.